All right, so we are on chapter 3-3, which is all about counting atoms. I wanted to start with a quick review. Recall all atoms of hydrogen contain one proton. I can find this by looking at the periodic table and finding the atomic number of the element. So for hydrogen, the atomic number is 1. Which means that no matter what, hydrogen will always have one proton. If you see an atom that does not have one proton, it cannot be hydrogen because the definition of being hydrogen essentially is that it contains one proton in the nucleus. Okay. Similarly, all atoms of helium contain how many protons? Well, if I look at the periodic table, helium is the second element on the periodic table. It has an atomic number of 2, so all atoms of helium contain 2 protons, no matter what. Okay, so finding the number of protons in an element is relatively straightforward. We're going to look for the atomic number on the periodic table, and whatever the atomic number is, that's going to tell us how many protons we have. Okay. For a neutral atom, which is mostly what we're talking about right now, okay, we haven't talked about ions yet. So for every neutral atom, the number of protons is going to equal the number of electrons. So in the case of hydrogen, they contain one proton and also one electron. Okay, so the number of electrons is equal to the number of protons. Similarly, all atoms of helium contain 2 protons and 2 electrons, because for right now, again, we're dealing with neutral atoms, so the charges have to be equal. If we've got 2 positive charges with the protons, then we've got 2 negative charges with the electrons as well. However, atoms can differ in the number, they can differ in the number of neutrons. So you can have a hydrogen atom that has 0 neutrons. You could also have a hydrogen atom that contains 1 neutron. So they can differ in the number of neutrons, and those are called isotopes. Okay, so isotopes are atoms of an element which have different masses because the number of neutrons is different. Okay, so let's take a look at a couple of examples here. Okay, I'm looking at the atom or the element hydrogen, and hydrogen apparently has 3 different isotopes. Okay, which means it has 3 different atoms which all differ in mass. The 3 isotopes of hydrogen are protium, deuterium, and tritium. Now, since these are all isotopes of hydrogen, then they should all have the same number of protons. And in the case of hydrogen, if I look at the periodic table and I find the atomic number of hydrogen, it's 1. So all atoms of hydrogen have 1 proton. So all 3 of these isotopes, they're all isotopes of hydrogen. They all have 1 proton. Because we're dealing with neutral atoms, they're also all going to have 1 electron. However, they do differ in the number of neutrons. Protium has 0 neutrons, deuterium has 1 neutron, and tritium has 2 neutrons. Okay, so these are all atoms of hydrogen. The only thing that changes are the number of neutrons. We can calculate the mass number over here on the side by simply adding up the protons and the neutrons. So the mass number for protium is 1 because 1 proton plus 0 neutrons is 1. The mass number for deuterium is 2 and the mass number for tritium is 3. If we know the mass number for a specific element, we can write that element using its mass number as such. Okay, so protium, I could also write it's hydrogen dash 1. It's hydrogen with a mass number of 1. Deuterium is also hydrogen, so I can write this as hydrogen 2, or sometimes we might say H1 and H2. Okay, and tritium is hydrogen with a mass number of 3. Okay, all of these are isotopes of hydrogen. They're all hydrogen atoms, but they differ in the number of neutrons. Dealing with mass number, remember mass number, I can find the mass number of any element by rounding the atomic mass from the periodic table. So take a look at carbon on the periodic table. If you find carbon on the periodic table and you look to see what is its atomic mass, carbon has an atomic mass equal to 12.011. Okay, so that's its atomic mass. If I round it, that means its mass number is simply 12. If I just round that down, carbon has a mass number of 12. Okay, I can find the number of neutrons by simply taking the mass number and subtracting the atomic number. Remember, the atomic number tells me how many protons it has, and the two particles in an atom that make up pretty much all of the mass are going to be the protons and the neutrons. So if I want to find the number of neutrons, I simply take the mass number and subtract the atomic number. And there's only one atomic number, not plural. So in the case of carbon, I can take 12, which is its mass number, and subtract its atomic number, which is 6, which gives me 6 neutrons. Now, what this means on the periodic table is that the most common form, okay, so the most common form of carbon contains 6 neutrons. Now, that's not the only form of carbon. You can also have carbon 14. So if I give myself just a little bit of room at the bottom, carbon 14, well, it's carbon with a mass number of 14. So if I want to find the number of neutrons here, I can take 14 minus 6, because again, carbon has an atomic number of 6. And 14 minus 6 is actually 8 neutrons. This is just an isotope of carbon, because it differs in the number of neutrons. So carbon 12 and carbon 14 are both isotopes of carbon. This one happens to have 8 neutrons. It's also a relatively unstable version of carbon. But we can always calculate the number of neutrons by just taking the mass number and subtracting the atomic number. Okay, so you can do that for any atom. If I give you the atom with the hyphen, that's giving you the mass number. Then all you have to do is find whatever the atomic number is, subtract the two, and you can tell the number of neutrons. The second thing that chapter 3-3 talks about is some concept called the mole. So before you start thinking about whatever this thing called the mole is, I want you to think about this. Okay, if I asked you, what is 1 dozen equal to? Okay, you go to the store and you buy a dozen eggs. How many eggs are you buying? Well, usually if you're buying a dozen eggs, you're buying 12 of them. Okay, so a dozen is simply 12 things. Okay, it doesn't have to be eggs. It could be a dozen anything. Sometimes you might get a dozen donuts or something like that. And so a dozen is simply 12 things. Okay, similarly, this new thing, the mole, acts just like a dozen. Okay, we use the mole to count really small things like atoms. An atom is super, super small, so I wouldn't want to count just 12 atoms because I wouldn't have enough to really do anything with. So a mole is used to count really, really small objects like atoms, and 1 mole is equal to 6.022 times 10 to the 23 things. Okay, this is a very, very big number. Okay, this is very big. Okay, and it's supposed to be a big number. The reason it's a big number is because, again, atoms are so small that I need to count a lot of them to really make any sizable quantity. So a mole is a really big number. It has a name, this number. This number is called Avogadro's number, and we will use it a lot throughout the year. Okay, so definitely memorize this number. I think it'll be pretty easy for you to memorize because you'll use it a lot in a lot of these example problems. But a mole is simply some way of counting a large number of things. Okay, in the case of an atom, 6.022 times 10 to the 23 atoms is 1 mole of atoms. But you can have a mole of anything. You could have a mole of basketballs. It just means you have 6.022 times 10 to the 23 basketballs, which is quite a few. Okay, that's a lot of basketballs. Okay, now 1 mole of any atom is equal to its mass number. No, not its mass number. Its atomic mass. Sorry. Its atomic mass in grams. Okay, so what I mean by that is 1 mole of hydrogen is equal to, if I find its atomic mass on the periodic table, its atomic mass is 1.008 grams. Okay, so apparently 1 mole of hydrogen, or 6.022 times 10 to the 23 atoms of hydrogen, is equal to 1.008 grams of hydrogen. Well, that's kind of interesting. Okay, can I do the same thing for the other elements? I absolutely can. 1 mole of carbon, for example. Okay, can you tell me how many grams of carbon that might be equal to? Well, if I look at the periodic table, a mole of carbon, the atomic mass of carbon is 12.011, so 1 mole of carbon is equal to just a little over 12 grams of carbon. Okay, and we can use that to solve the following problems. Okay, so the biggest part of this chapter are being able to solve these mole conversion problems, which are quite tricky, okay? But they're always set up the same every time. As long as you set them up the same every time, you'll have no problems. Okay, so example 1. It wants to know what is the mass in grams of 3.5 moles of copper. Okay, so we set up our equation the same every time. I want to know, what is this question asking? Well, it's asking what is the mass. So I'm going to start X grams of copper, because that's what the question's asking for. And I'm going to set that equal to whatever they give me. So in this case, they give me 3.5 moles. So 3.5 moles of copper. Okay, so every problem is going to be set up the same way. X, whatever they're asking for, is equal to whatever they give me. In this case, they give me 3.5 moles. Once we have that set up, we then need to multiply by some conversion factor. Now, I might not know exactly what that conversion factor is yet, but I'm always going to multiply by some conversion factor. So I'm always going to do times and then this fraction bar, this line going across. Here's the way that this works. I need to convert from moles to grams somehow. Okay, it might take me a couple of tries, but that's okay. I know, though, if I'm going to get from moles to grams, I need to cancel out this moles somehow. I don't want to be stuck with that moles at the end of the problem, so I need to cancel that moles. In order to cancel it, I'm going to put moles of copper on the bottom of my fraction. If I put it on the bottom, it's going to cancel with that one on top, and hopefully I can convert it into something else. Okay, now, do I have a conversion where I can convert 1 mole, okay, I don't even need to say moles, okay, but do I have a conversion where I can convert 1 mole of copper into something useful? Okay, well, it turns out I actually do. Because if I look at the periodic table and I try to find copper, 1 mole of copper has to be equal to its atomic mass in grams. So looking at the periodic table, I try to find copper, which is right in the middle, element number 29. And it turns out copper has an atomic mass of 63.546. So that means 1 mole of copper must be equal to 63.546 grams of copper. Once I've done that, I notice moles on the top and on the bottom cancel, and I'm left with grams copper at the top. I was looking for grams. I now have grams, so I'm done. All I have to do is plug this into my calculator. 3.5 times the number on top, which is 63.546. I don't have my calculator here, okay, but if you were to calculate it, you should get, I don't have my calculator, interestingly. Okay, but if you just multiply those two numbers together, you should get your result somewhere here. Okay, all right. Problem number 2. A chemist produced 11.9 grams of aluminum. How many moles were produced? Again, we set up the problem the same every single time. Okay, so in this case, it's what is the question asking for? Well, it's asking how many moles were produced. So I start X moles of aluminum is equal to, what do they give me? Well, they give me 11.9 grams of aluminum. So I write my 11.9 grams of aluminum, and for all of these problems, I'm always going to multiply by some conversion factor. Question is, what is that conversion factor? Okay, well, I don't know exactly what that conversion factor is, but I do know if I need to convert grams into moles, I need to get rid of this gram somehow. So grams of aluminum I know is going to go on the bottom to cancel out with that grams on the top. Now, do I have some conversion factor that I can use to convert grams of aluminum into moles of aluminum? Okay, well, it turns out I do. I know that 1 mole of aluminum is equal to how many grams of aluminum? Well, let me look at the periodic table, and again, if I find its atomic mass, that should be in grams how much 1 mole is. So 1 mole of aluminum is 26.982 grams. So I write down 26.982 grams on the bottom is equal to 1 mole on the top. And notice my grams of aluminum cancel. Okay, so I'm left with moles of aluminum. I was looking for moles of aluminum, so now I'm done. All I have to do is take my 11.9, and this time, since my second number's on the bottom, I'm going to divide by 26.982 grams. Okay, and this should give you the number of moles of aluminum. Okay, let's go through 2 more. Example 3, how many moles of silver are in 3.01 times 10 to the 23 atoms of silver? Okay, when we do this, we're going to say, again, what is it that I'm looking for? I'm looking for moles of silver, so I start off with X moles of silver is equal to, what was I given? 3.01 times 10 to the 23 atoms of silver. I always multiply by my conversion factor. If I want to cancel the atoms of silver needs to go on the bottom. And what do I know? Do I know some way to convert atoms into moles? Well, if I look back at the top, under our notes about the mole, I know that 1 mole is equal to 6.022 times 10 to the 23 things. Well, in this case, 1 mole can be 6.022 times 10 to the 23 atoms. So 6.022 times 10 to the 23 atoms is equal to 1 mole of silver. I can cancel my atoms, and I'm left with this divided by this. And that should give me my moles. When you plug this into your calculator, always remember to put both of these in parentheses so that way they all stick together. Okay, they're all one thing. So what I would plug into my calculator would be 3.01 times 10 to the 23 divided by 6.022 times 10 to the 23. And when you divide this out, I think you get 1/2. Okay, should come out to be about 1/2. Like 1/2 moles, I guess. Okay, let's try one more. What is the mass in grams of 3.01 times 10 to the 21 atoms of cobalt? Again, what is it I'm looking for? I'm looking for mass. And mass is measured in grams, so X grams of cobalt is equal to, they give me now atoms. So then I need to multiply by my conversion factor. In this case, I need to cancel out atoms, so atoms has to go on the bottom. Do I know a conversion involving atoms? Well, just like the previous example, I know that 6.022 times 10 to the 23 atoms is equal to 1 mole of cobalt. Okay, then I'm not finished yet because my atoms do cancel, but I'm left with moles of cobalt, and I'm actually looking for grams of cobalt, so I need to go one step further. I know that 1 mole of cobalt must be equal to some number of grams by looking at the periodic table. Okay? And if I find cobalt on the periodic table, I find that it has an atomic mass of 58.933. So 1 mole of cobalt must be equal to 58.933 grams of cobalt. Once again, moles on top and on bottom cancel, and now I just have to plug all this into my calculator. Notice, this is on top and this is on top, which means they're going to multiply together. So I'm going to have 3.01 times 10 to the 21 times 58.933. And all of that's going to be divided by what's on the bottom, which is this one, 6.022 times 10 to the 23. Okay, when you compute this, you'll get an answer, and that should be in terms of grams of cobalt. Okay, once again, I don't have my calculator here, otherwise I would calculate it. Okay, and that should be just about it for section 3.3. If you look on page 93 of your textbook, there are some practice problems that you can do there. Problem 17, 18, 21, 22, 23, 24. Those ones you can work on as practice. If you want to see the answers, I have the answers as well, so you can always come check with me. All right, best of luck.